Welcome back to our lecture 5 on quality management. So previously we already had 3 parts on quality management. So let's have a brief recap. So first of all, we started with understanding the 8 dimensions of quality management. We talked about order winning versus order qualifying elements, and after that we have a short discussion about internal quality failure and external quality failure. Then we went on to technical dimension and organizational dimension. We talked more on the side of organizational dimension, and then we went through improvement dynamics. I use this logical diagram to explain about the deviation, tolerance level, significance of the quality issues, and then we went until here, which is also emphasized about I gave a brief introduction about outlier, and I emphasized about basically deviation, which is a significance of the quality failure or the quality issue, which is how far away it is from the mean, how far away it is from the average. And in this part, which is our last part, I try to keep this lecture, this video short, because we're already into part 4 of quality management. This is probably the longest lecture in our course series. And we're going to continue with our quality management, and today we're going to be emphasizing about statistical process control, and we're going to be talking about I'm going to introduce to you arrow 1 and arrow 2. Both are arrows in terms of quality defects. Okay, so first of all, I'm going to start with quality control. So remember in the last lecture I gave some kind of a definition. I mentioned before that if this is a mean value, the yellow dot right here, definitely not all products are going to meet the requirements. So some products can be here, some products can be at this point, and some can be far as the red dots here, both the red dots here, and they might be considered as outlier. So an outlier is basically a data that's really far away from the average and far away from other data in this sample of values. So sometimes we set a target value to be a certain point, and sometimes they doesn't go that optimistic. We can see our values in different points. They may be here, they may be here. If you want to have a calculation on whether it is outlier or not, we have an outlier test which we address as a numerical rule. So outlier test is basically you should calculate the interquartile range, and after you calculate the interquartile range, you times 1. After that, you times 1.5, and then you'll see if the value is lower than the first quartile, is lower than 1.5 times interquartile of the first quartile, or higher than that of the third quartile, then it's considered as an outlier. So this is a test that you can identify whether your product is an outlier. But it really depends on what you set it. So for some products, it's okay to have some differences to the mean, but for some products, even the bit quality difference is not acceptable. So really depends on how do you identify your outlier. Maybe it also depends on how are you going to identify what is your tolerance level. So you try to fix these issues. And this is about statistical process control. So we have something called deviation that I've introduced to you guys in the last video. So deviation is basically the difference between X, which is your outcome, and G, which is your goal. So the difference between outcome and goal is basically deviation. And you can see that when we have the mean value here, a fairly more successful production, maybe fairly more successful product quality, maybe this curve right here, because as you can see from this curve, we actually there's a less distribution, so there's a lower standard deviation from all these data. Basically, I've talked to you guys before, standard deviation measures how far away are the values from the mean, from the average point, means average, and this basically, if we see this curve right here, you can see basically all the data are quite close to the mean, which is right here. All the data are relatively closer. And on the other hand, for this curve, for the second curve right here, definitely you can see the data more distributed away. That means maybe for example, if I'm producing a CPU, if my target is to produce maybe speed of 3.5 J hat Z right here, maybe they are relatively too slow CPU, and they are CPU with too high speed. So definitely this those extreme values on the side are basically considered as outliers. So this is from an analytical perspective. When we use statistics to show our data, you can see by the curve, by the shape of the curve, by the measurement of the standard deviation, by the variance, by the t-score, sorry, z-score. By these three, I'll list it down for you. By standard deviation, variance, and z-score, you are able to identify how far away are the values from the mean value in order to make decisions make decisions on whether your product meets the quality or not, or whether most of your products are not meeting your requirement, or some are meeting the requirement but there are some kind of outlier. So you can do more of your personal research on your own time as well. Then we go to here, then we go to this point. Sometimes we actually can shift our mean average. So first of all, in this curve here, you can see mean average is right here, and the second curve, the mean average, it actually goes here. This doesn't show curve from two different companies, it actually comes from one company. So this is basically the process of shifting the curve. So the curve has been shifted, the mean average has been shifted. Shift of mean. So what does this mean? Because after most of your products are too far away from the mean, they don't really correspond to the mean, actually they might have a shift, so they will have kind of a new mean actually. So there should be an assignable cause that is affecting the mean, that is a cause that actually is not random cause, since it affects many if there's a shift of mean, it means it affects most of your products, resulting in a total shift of the mean. This means that many products are actually far away from your required kind of a requirement and for a goal, so it kind of shifts the mean. So there should be assignable cause that we can also give a definition as a specifiable cause, or a reasonable cause that has a reason. Specifiable cause, it is an identifiable cause in the system. So basically, it's a certain cause that is not random. It's not random. It is affecting. It's actually a root cause, actually a plausible cause that is affecting this system. Rather, it's possible to be fixed, rather than it's kind of something random that kind of you cannot trace a reason. Something like that is different. So actually, it's an assignable cause right there we're seeing. So I just want to tell you guys, this curve actually can shift. Okay. Then let's look at here. So our target points right here, and we can see there are some outliers happening in this graph. We can see some dots actually going to the UCL. What does UCL mean? It's really simple. It means upper UCL basically means upper control level. Upper control level. It is even upper, it is going more upward than our control level, and LCL means lower control level. So when we have points reaching close to this, or even you can see the two dots here reaching over the UCL, basically they can be considered as outlier, and this can be an issue, because then it means it is out of control. The quality is out of control because you have certain products that are out even in the upper level, upper tolerance level, as you designated. So we'll look a bit later. We'll look down more specifically. So now I'm going to introduce to you guys what are type 1 error and type 2 errors. These are two errors happening on your quality defects. So the first error is basically when you say out of control wrongly when it is in fact in control. So in some circumstances like this, for this point right here, it really depends on the product. For some products, it is possible. Well, this point seems like an outlier. It seems more out of control. But for some companies, for some product types, it is actually within the tolerance level. So it really depends on a company. There's no theoretical rules for general business world. But for this circumstance, for example, this one may seem like out of control, but it may be classified as in control. So then you made a type 1 error right here by classifying this point as out of control. So what happens when you have some type of type 1 error, when you think your products have some quality issues? Well, it is actually within your tolerance range, and you are actually accepting this problem. So there are two ways you can do it. You may still conduct a learning, so you try to learn, maybe conduct some cause and effect, do some experimentations to find out the real cause behind. And the second way is actually just to ignore the problem. So this problem is not really severe, so you have a type 1 error. Maybe you still fix the problem, you add in more cost, but maybe you don't have the necessity to actually fix these problems. And then the opposite is actually type 2 error, which is when you say it's in control wrongly when in fact it is out of control, which means what you believe, although it seems like maybe it can be an outlier, maybe it's quite far away from the average, you still accept the product's quality as it is in control. You believe it is a possible tolerance. You are able to tolerate this product, but actually in fact it can be out of control, which means it's actually out of your actually acceptable quality range. Why can type 1 error and type 2 errors be made? The answer is basically sometimes you are not making the correct measurements, or sometimes you are ignoring some quality defects while you're studying and measuring these products. So you should basically try to avoid type 1 and type 2 error and try to conduct more accurate measurement, conduct more thorough, more rigid measurements and checks in order to don't stop avoiding cost. Because for type 1 error, what happens is if your product is really in control, if there's really no need to actually spend cost to fix the problem, your view, your perspective on it is out of control will actually add more cost to this product, because you then have to fix and conduct maybe learning to fix this product. And in type 2 error, when it's in control, this is even more costly than type 1 error by a lot, because that means you believe your products are meeting the quality requirement. There are two ways you can incur some cost. First of all, if you believe that it is in control, but before you publish in the market, you found there are some problems, it might be time cost, because you will publish this product slower to the market. That is internal cost. It is not as high as external control, which is the other hand. When you have external control, you think your product is okay, but when you publish to the market, no, customers find out some issue with that. Then you identify some defects, some loopholes with your product, and there's no turn back chance to fix. So that's external cost. So you try to use your technological development, use available skills and capabilities to try to reduce your type 1 and type 2 errors. So let's look at the graph here. Type 1 error can be things like this. When it is within the LCL and UCL, by you believe it is out of control, out of the bounds. And for type 2 error, maybe circumstances like this. When assignable cost hits, when your assignable cost hits and your product is reaching LCL using the UCL, you still believe it is in control, but in this case, it's actually out of control when it is going to violate. But it really, in the end, really depends on your criteria you set for your businesses, and depends on the product you produce. Because for some products, there's really no need to basically some products there's a broader acceptable range, there's a higher tolerance range for certain quality issues, but for some products there's no issue there's no tolerance. For example, for meat, although I don't support meat that's dirty, but if there's some meat there's with a little dirt, that's not a severe quality issue, that's acceptable, because as a buyer, as a consumer of a meat, and you can clean it at home. Same for vegetables, fruits, you can clean it at home. So these are not really severe quality issues. But for some technical products such as a smartphone and computer, some quality issues may affect the computer in certain functions, and may affect computers in many ways, from the fundamental way in terms of the speed, in terms of a loading of websites, application, in terms of a mouse, it can, in terms of your user interface, there can be a lot of effects, a lot of severe effects, and it can be really costly. Okay, so that's pretty much about it. And lastly, how about process capability? So customer specification usually have a tolerance range. I would say it depends, but usually have certain tolerance range. For example, if we compare company A and B, company A is right here with its process distribution, which is closer to the mean I mentioned before, lower standard deviation, and company B has a process distribution quite far away compared to relative to A, it has a far distribution compared to the mean, so there's a higher standard deviation. So in this case, a lower limit of specification. There's a higher limit of specification. So in B's case, B is actually having outlier. Is maybe B is required to fix these issues. And for A, if, in this case, they are within the process the tolerance range. So maybe this should be okay. Okay, so this is pretty much about all we discussed so far about quality management in this course. So this is our end of a lecture for quality management. So in this video, our focus point is basically to identify the more. We're actually identifying the type 1 and type 2 error, and identifying about what do we call as in control and out of control and in control, and we're you should keep in mind that it really depends on company and depends on product that you're making. So also I'm giving you kind of a brief introduction, a brief start to how to use a graph to display this data, which we commonly use is kind of like a bell-shaped graph, because we use this graph to kind of list out what is our mean, and we might be able to plot maybe into the line overlapping the line, or maybe we plot the point outside depending on what our data is. And in that way, and combining with some certain calculations such as standard deviation, variance, and z-square, we are able to analyze whether there are many. We are going to analyze how far away are the product's quality from our requirement, mean our target goal, and then it depends on your tolerance range, depends on your decision, depends on your products, your nature of your products, depends on your tolerance range, and then you're going to make changes to your products or not. So it's up to your own decision depending on your business a lot. So this is pretty much all about quality management. So I think I've done a lot of conclusions on recap, so I'm not going to go through what we learned through this whole lecture again. In the next lecture, I'll be focusing on new product development, so we are going to take away quality first, and we're going to be discussing a new called CFT, an innovative approach to produce a product from the concept stage to the design stage, to the prototype stage, to the manufacturing stage, to the marketing stage, and to the services stage. We're going to compare two of these approaches. So lecture 5 will be broken down into 2 parts, and in lecture 6, we're going to get to steps that are more practical, based on supply chain management in terms of strategies and operations. Okay, so this is pretty much about the quality lecture here. So if you have any questions, please comment below. If you want to study more of related concept, you should explore more on your own to explore some different strategies, different calculations, different statistical measures, and those kind of technical skills in order to analyze the quality and make the right changes. Okay, so I'll see you in the next video, and thank you for watching.